These are your 1-7 notes on functions. This will wrap up chapter 1 for us. We're going to talk about those relations a little bit. We're going to classify them as a function or not. And then we're going to just do some function evaluation. So a function is just a relationship between the domain and the range of that relation we talked about in the previous section. So is there a relationship? Is there rhyme or reason? Is there a pattern being formed? Each element of the domain is paired with exactly one element of the range. So if that happens, the domain cannot repeat, but the range can repeat. And not all relations are functions. So we're going to take a set of ordered pairs. We're going to look at a set of ordered pairs and determine whether or not it's a function. And really, the big question is, does the domain repeat? So it cannot repeat if it's going to be a function. A discrete function is a graph consisting of points that are not connected. They're non-continuous. So this is a function because when I look at it, they all have different x values. The domain did not repeat. So I can clearly see that just by looking at it, glancing at it, that none of the domains repeat. So that's a function, but they're all just scattered. A continuous function is a graph consisting of a line or a smooth curve. So this is a function. This is actually something cubed. So this would be like the function f of x is equal to x cubed plus 1 maybe. Okay, and again, the domain didn't repeat, but it's all of those values. So it's all of the fractions and decimals, whole numbers, positive and negative that make this up. And because there's all of those numbers, all the rational and irrational numbers are included in here, it becomes a continuous curve. But up above, we didn't continue, it's not continuous because we didn't include all of those fractions or decimals. If I were to actually just maybe make my coordinate plane like so, you could see that this is -1, 0 here, right here. This would be -2 and maybe 1.5. This is the ordered pair -3, 1. I've got 0, 2 on there, and I've got 1, 2 on there. So it's just those ordered pairs, nothing in between them. If you were to connect those, you're talking about all the fractions and decimals that belong between them. So discrete is not connected, continuous is a continuous line. The vertical line test is the quick and easy way to determine if you have a graph that's a function. So if a vertical line intersects the graph more than once, then it is not a function. So if I look at all of these values here, this right here is a representation of a function 4 different ways. It's the same 4 functions. So here's the equation. There's the equation. If I were to plug any one of these x values into that equation, I would get these y values. So here's a mapping of those same ordered pairs. And then this is just taking it to the graph. So I know I only showed 3 ordered pairs in the table and 3 ordered pairs in the mapping, but when you have an equation, it becomes an infinite set of ordered pairs. Now if I take a vertical line and I just envision this vertical line crossing across this graph, it never touches the graph in 2 spots at a time. Everywhere it stops, it's only hitting that blue graph 1 time every single time. So this graph is a function. So you can just visualize that vertical line going past, and you can say whether it's a function or not. So we're just going to go through and we're going to look for if the domain repeats in different forms of representing a relation. So we're going to decide whether these relations are functions, and then we're going to say if it's discrete or continuous. So number 1, it's a set of ordered pairs. I could technically graph it, but all I'm looking for is the domain, if the domain repeats. And I see that the domain repeats right there. -1 gives us 3, and -1 gives us -8. Therefore, I couldn't have a function that does both of those. The domain repeats, not a function. If it was a function, we'd say it was discrete, but it's not a function, so we don't have to name it. Number 2, I'm looking at the mapping. So I'm just now looking, same idea. I could write it as a repair. I could graph it if I needed to, but I'm just making sure that the domain doesn't go to this 2 different ranges. So -5 goes to 6, but -5 only goes to 6. -4 goes to 9, 2 goes to 1, and 3 goes to 9. So I see that -4 and 3 both go to 9, but that's okay. Because as an ordered pair, that would be -4, 9, and that would be 3, 9, and the domain is not repeating. That's okay. It's only the range that's repeating. Again, that's okay. So this is a function. If one of those domains had a double arrow coming from it, we'd have a problem. And it's discrete because it's just a set of finite ordered pairs. It's not everything in between. Number 3, I'm going to take my vertical line, and I'm going to cross it across the path of this parabola. That's what that graph is called. And it hits only once, just like in the example on the last page. So this is a function. But because all those ordered pairs, that's what these blue lines represent, this curved line, is all the ordered pairs that are included. And the arrows here and the arrow here says it goes on forever and ever and ever. So because there's no gaps in between this, it's continuous. We're not excluding. Every single x value is included there. X equals -4. It's an equation. They gave me an equation. When it's given as an equation, it's continuous. And I'm just going to go through and come up with some scenarios. I'm going to give some ordered pairs. -4, 1. -4, 2. -4, 0. I'm giving you all of the scenarios that make this statement true. Is x equal to -4 in all 3 of those ordered pairs? Yes. There is no y. The equation doesn't care about the y. And so all 3 of these belong to this relation. If I were to graph these, I'd get -4, 0, -4, 1, -4, 2. I could continue onward, but I'm getting a vertical line. And so because I'm getting a vertical line, it does not pass the vertical line test. So it's not a function, because the domain repeats over and over and over again. Function notation is another way to write equations of functions. And I think I showed this on the first screen, forgetting that you might not have ever seen that. So if I have the equation y equals 2x plus 1, it's just the same thing. It's just instead of saying y, I'm going to say f of x is equal to 2x plus 1. Okay, it's sort of an input-output thing. So what you're saying is, I'm going to plug in an x value into this function. I'm going to place x here, and it's going to give me my output. Okay, so down below, f parentheses x reads f of x, the function for this value of x, the function for 5. F parentheses 5 reads f of 5. It means the value of the function when x is 5. So if I were to do f of 5 for the function up above, that means I'm going to evaluate sorry about that. I'm going to evaluate this function in terms when x is 5. So the function when x is 5 is equal to 10 plus 1. So f of 5 equals 11. It's just another way of looking at an ordered pair. Really what we're saying is 5, 11. When x is 5, y is 11. So y and f of x are really just interchangeable. You need to get used to that. It's sort of a grown-up way to write an equation. All right, so I need you to determine whether the following relation is a function. If so, is it continuous or discrete? Oh, I don't have one there. And then find the value of h of 2 for the function h of x is equal to x plus 5. Give me 1 second. There we have it. So tell me whether the following relation is a function, and if so, if it's discrete or continuous, and then evaluate your practice problem. Good luck.